In this video we're going to practice drawing some organic molecules. We're going to use the displayed formula, the skeletal formula, and we're going to see if we can name them as well. One of the key things that we'll be doing is looking for the longest carbon chain when we name our molecules. We can see from this screen we take the first 6, so probably from GCSE, so we've seen the meth, eth, prop, bute, and then when we get to 5 carbons in a row we've got pent, 6 is hex. We might also see ones where it's 7 carbons long, so that will be het, and 8 carbons oct. The first molecule that I want to look at is this, and there's its displayed formula showing all of the carbons and the hydrogens and the bonds. If we wanted to draw this skeletally, then we just need to match the skeleton with the number of carbons that we've got. So there we've got 5 carbons, and we would draw them as a zigzag, like so. Of course not showing the yellow blobs. And to name this, we've just got a chain of 5. So this molecule is pentane. Here's another example. See if you can draw this skeletally. So again, we're looking for the carbons in the skeleton. So when we put this together, we have 5 carbons in the backbone, and then on the second carbon in the chain we have a methyl group coming off, like so. So again, the longest carbon chain is 5, so that makes it pentane, and we have a group of 1 carbon coming off, so that's a methyl group, and we need to say where that's appearing on the carbon chain, and we need to make the number as low as possible, so we'd number from the right hand side, which makes this 2-methyl pentane. Let's have a look at another example, see if you can draw this one out skeletally. So as I've drawn it there, again we have a chain of 5 carbons, and then on the second carbon we have C2H5 coming off. So that's a skeletal representation of this molecule. Let's see if we can name it. Well, it's quite tempting here with the way that it's drawn to think that the longest carbon chain is 5 with an ethyl group coming off, but of course actually the longest carbon chain is not 5 but 6, and rather than there being an ethyl group we have this methyl group. The methyl group appears on the 3rd carbon, so this is 3-methyl, longest carbon chain was 6, hexane. In the next example, let's see if we can draw this skeletally. So we have the 5 carbons across the middle, and then 2 methyl groups, so our skeletal should look like that. Let's see if we can name this. So the longest carbon chain is 5, which makes this a pentane, and then we've got 2 methyl groups highlighted there. So where do the methyl groups appear? Well, we have to go through numbering the carbons. So we have one methyl group on the second carbon, one methyl group on the fourth carbon. So this is 2,4-dimethyl pentane. Let's have a look at this next example, looking a little bit more complicated now. So first thing to do is establish the longest carbon chain. Which is that. So that's 8 carbons in a chain, so this is an octane. And then we need to spot the side groups that we've got. We can probably see that we have 1, 2, 3 methyl groups, as well as 1 ethyl group. We then need to number where these groups are, and we will need to keep the numbers as low as possible, which means in this example we need to number from the right hand side. So if that's carbon 1, that's 2, that's 3, and that's 4. And so to put the name together, the ethyl group comes first, so we're putting them alphabetically, which means we're looking at 4 ethyl, and then we have 3 methyl groups, 1 on the second, 2 on the third, so that's trimethyl. So 2, 3, 3, trimethyl octane. This next example contains a couple of halogen atoms. Let's draw it out skeletally. Let's look at the carbon backbone that we have. So we have a chain of 4, and then there's a methyl group on the second. So looking something like that, and you can see we've got a bromine there and a chlorine there. So there's our skeletal representation. And now for the name. So the longest carbon chain is the 4 again, which makes this butane. And then let's have a look at the groups that we've got. Well, we've got the chlorine, which is going to be a chloro, the bromine, which is going to be a bromo, and we've also got the methyl group. In terms of numbers, we need to make the numbers as low as possible. So in this case, we're going to number from the left hand side. So that's going to be carbon 1, 2, 3. So let's put the name together. So we're going in alphabetical order for the groups. So bromine coming first, so that's 2 bromo. Then we've got the chlorine, so 1 chloro, and finally the methyl, 3 methyl butane. We'll just finish off with a few cyclic alkanes. So here's the displayed formula. We have a ring of 5 to draw the skeletal for this. All we're going to have when we get rid of the carbons and the hydrogens is what will look like a pentagon, and this is cyclopentane, so a ring of 5. Here's another example. This time the ring is of 6. So drawing skeletally, we would just see a hexagon, but in this case we also have a methyl group, which we can put anywhere on the ring. So there's our skeletal, and the name, well, it's cyclohexane with a methyl group, doesn't matter where that is, so just methyl cyclohexane. Here's the final example in this video. See if you can draw this skeletally. Well, the cycle is made up of these 4 carbons, which we represent as a square, and then we have the 2 methyl groups attached, so we'll put one there and the other one on the adjacent carbon. In terms of the name, we have the 4 carbons in a cycle, which makes that cyclobutane, and then the 2 methyl groups, and again we want the numbers to be as low as possible, so if we call that one 1 and that one 2, then we're looking at 1,2-dimethyl cyclobutane.